So first one here, these are not formula that can be found in a formula list. The first few, you should be able to relate them well later on. When you see a power n, let's say you have a fx to the power of n. In order to integrate a term like this, you want to make sure that you create the f prime x. So the derivative of the bracket must be created outside before you start any integration. And when you integrate, this is like your usual. You do power plus 1, so you get n plus 1, divided by the new power plus c. But you must make sure that you create this term, create f prime x. Okay, let me remind you on that. And also, this n can be any number, but just not 1, right? Not minus 1. If it's minus 1, it will be the second case that we will see later on. So n can be any value, can be decimals as well, but not minus 1. So let's observe, when I see a question has a particular power, this 5 is like the n, then we will judge that this term within that power is your fx. You want your fx to be x squared minus 3. You don't need to write this, but you can prepare for what is f prime x. F prime x will be 2x. Make sure you let the one in the bracket be fx. You differentiate, you get 2x. So to start integrating this particular term, let me just copy exactly first. You want to force in the f prime. So in this particular example, I want to place a 2 in front, and you balance outside your equation with a half. Okay, any coefficient you create, you balance outside. Hence, leave the half there. When you integrate, the f prime will not appear as part of the answer. F prime will disappear. Hence, 2x will be completely gone. I will only be left with that x squared minus 3 power plus 1 divided by that new power plus c. So one way to judge this kind of questions for simpler questions is on the degree. If you see that the term inside is degree 2, I expect that f prime outside must be degree 1. F prime always will have 1 degree down if you are doing differentiation. But this is only true for polynomials. Later we will see other types of questions. Now, second example, you may not see it on first glance, but if you observe the powers, you will understand that there are similar things. This is degree 2 at the top. At the bottom, this is a degree 3. So it's like you have a f prime and fx kind of format. Write it in this structure that we understand better first. You want to have f prime fx power n. So when I rearrange this equation, the 3x squared plus 2, we write it on the left. Square root is treated as a power. In particular, square root is a power negative half. Then simplify your equation. Again, this is your fx. In this particular equation, if you differentiate this fx, you will see that immediately this term is your f prime x. You differentiate this fx, you get f prime x. So we already have it in that structure that we are looking for. We can start straight away with your power plus 1, which you get half. Divide by that new power plus c. Okay, next problem. When you have f prime over fx, then you go for ln. Okay, so ln always comes with a modulus. You can only remove the modulus if fx is more than 0. Okay, just put a note by the side. Remove mod if fx is a positive term. The logic is because you always want to ln a positive number. Okay, so the relation is actually, if this is a minus 1, okay, if your n is power minus 1, it's treated as the second case. Power minus 1 means you can move it to the denominator as degree 1. Okay, that's why the first case cannot be minus 1. If it's minus 1, it belongs to the second formula. Okay, so let's try to work it out. F prime over fx. Here you do get that relation because it's degree 1, degree 2. So f prime over fx, let's try to create that term. At the top, you will get minus 2x. You balance your equation outside, you get a negative half. Simplify, so we get negative half ln, and you mod the denominator plus c. If we try to apply now both things together, let's start from the left. Okay, you will see similar things appearing. There is a 1 over x on both, but the one on the left is multiplied to ln x. The one on the right is divided by ln x. So what is the difference? For you to see these two clearly, understand first that the relationship is whenever you have fx is ln x, it's related to f prime, which is 1 over x. This two has that relation. One is fx, one is f prime. So the first formula on the left here will then read as, this is of the form 1 over x ln x power 1. It is the first formula that we have done above, such that this is your f prime. This ln x is your fx. We have it of the form f prime x fx to the power of n. So to integrate this means you go for your power plus 1, so you get ln x squared, divide by that new power plus c. 1 over x, again, the f prime will not appear in the final answer. For you to see the second one clearly, I would like to do a rearrangement. We will treat this as like it's 1 over x times 1 over ln x first. Let's do a split up as a multiplication. Multiply 1 over ln x is the same as you divide ln x. But in order for you to see the integration, I am going to combine them to one term. So when I combine, this ln x now goes to the denominator like a fraction. Which means in this structure you are looking at, it is f prime over fx. It's now that second formula that we have learned today, f prime over fx. What will you get in the integration? You get ln of the denominator. So it's double ln because of the format f prime over fx.